So this is a video lesson for chapter 10 section 1. We're almost finished with our year here. So one of the last things we're going to learn are the quadratic equations and the parabolas that they form. So we're not going to do a whole lot of graphing, but you are going to be looking at quadratic equations, looking at the parabolas or visualizing the parabolas that they project, and then you're going to be comparing them and telling me what are the differences and such. So before we actually get into that, first of all, we need to understand what a quadratic equation is. And this is a quadratic equation. The generic quadratic equation looks like that. You'll have an x squared with possibly something in front of it, and that is a. A can be any number, plus bx, and the b can be any number, plus c, and c can be any number. So a quadratic equation looks like this. Sometimes some of this will be missing. You'll always have the x squared, which kind of makes the quadratic equation what it is. But you might have the b be 0 and sometimes the c is 0 as well. So all you have is the x squared with possibly something in front of the x. So the simplest quadratic equation is this one right here. Y equals to x squared. So that's as simple as a quadratic equation gets. In this case, the a is just a 1. The b is not there, so the b is a 0. The c is not there, so the c is a 0. And that is as simple as a quadratic equation gets. Now, quadratic equations form parabolas when you graph them. We're not going to do the graphing portion, but if, for example, you were to graph this particular parabola, the y equals to x squared, you would have a parabola that looks like this. Obviously, this isn't 100% to scale or accurate, but that's close enough. So you would have a parabola that looks like this, a very generic parabola, open-ended, both ends go on to infinity. So yeah. Now that's a parabola. It's a when you graph a quadratic function or an equation, that's what you will get, some sort of a parabola. Sometimes they face in different directions, they're wider, narrower, and such and such. The vertex is this point right here. It's the highest or the lowest point of the parabola. In this case, for this parabola, it's the lowest point. Always the highest or the lowest point. The axis of symmetry is a line that divides the parabola in half. In this case, our axis of symmetry, let me use a different color, let's say blue, is this line right here. And I traced over the y-axis. So for this parabola, the y-axis, specifically y equals to 0, is the axis of symmetry. It's the line that'll split the parabola in half. So lowest or the highest point, the line that splits the parabola in half. The parabola itself is a graphical representation of a quadratic equation. And a quadratic equation is an equation that will have this form: y equals to, and I forgot to write the y equals to that. So y equals to something with an x squared. You at least have to have the x squared. That's what makes a quadratic equation quadratic. Linear equations and linear systems, you remember that when we graphed them, they form just lines. They had the x to the first power. So the parabola, the curved line, results from you taking that x to the second power. All right, so great. How does that relate to what we're going to be doing? Well, let's take a look at a few examples here. All right, so this is our baseline, and you always compare to the baseline, at least we will be. So the y equals to x squared is the very simplest case. This is an approximation, not an actual. The actual graph might be a little bit different, but for our purposes, it'll do. So this is the parabola that, let's say, represents the y equals to x squared. Now remember from the previous slide, you could have something in front of that x squared and the a. So looking at the first graph, what's the a? Well, there's nothing in front of the x squared, and if there's nothing to be seen, there's always a hidden 1. Okay? So there's always a 1 in front of that x squared if there's nothing else, and that's the baseline. The 1 is the baseline. If the value in front of the x squared changes from the 1, so if the a changes one way or another, the parabola will shift. Let me rephrase that. The parabola will resize itself. So let's say we give the a value of 3 for this particular parabola. So we get 3x squared. If the number is greater than 1, so if a is greater than 1, the parabola will shrink or narrow down or become more acute. So the parabola will squeeze in, become narrower, or become more acute depending on how you like to phrase it. So anytime you have a number that's greater than 1, and the larger the number, the narrower the parabola gets. So if this was a 5, the parabola would be even narrower. If that was a 2, the parabola would be slightly wider. And 1 being kind of the baseline. If let's say my y is less than 1, and let's say it's a fraction, let's say a equals to a 1/2. If it's less than 1, it has to be a fraction or a decimal. We don't deal with decimals. If the number is less than 1, for example 1/2 x squared, the parabola actually widens. It expands from the original y equals 2x squared. Obviously, again, these are not 100% graphically accurate. It's the best that I can do. But the whole idea is that if the number in front of the x squared is greater than 1, and here there is that hidden 1, the parabola actually starts to narrow down. The larger the number, the narrower the parabola gets. If the number in front of the x squared is actually less than 1, and I don't mean less than 1 in terms of positive and negative, I mean as you approach 0. So fractions less than 1. So a half, 3/4, 1/3, 1/4, 1/5, and so on. As the fraction gets smaller, as the fraction gets closer to 0, the parabola widens, and obviously at 0, the parabola is fully expanded. It just lies on the x-axis. So if it's slightly higher than 0 but less than 1, the parabola just is pretty wide. So that's the first case. If the number in front of the x squared changes, so if it's greater than 1, the parabola narrows. The larger that value, so if this was a 10, this would be a very skinny parabola. If this was 100, it would be a really skinny parabola. Same thing here. As the fraction becomes smaller, the parabola widens. So if I gave you a 3/4, 3/4 is greater than a half. The parabola actually is going to be a little narrower. If I gave you 1/3, 1/3 is less than half. The parabola will actually be wider. All right, great. So let's take a look at something else. Let's take a look at these three cases. Our baseline, the y equals x squared, which we're familiar with, and then two new cases. So now what's different here? Here we have a negative in front of the x squared. Over here we have a negative 2x squared. Now we know what to do with the 2. If the value is larger than 1, we now know what to do with this, but what do we do with the negative? So I'm going to show you what that looks like. So let's assume that's the parabola for our baseline, y equals x squared. Again, I'm not sure that's 100% graphically accurate, but that's pretty close. It's close enough for our purposes. So if that's the baseline, if the number in front of the x squared is negative, so it's positive here, it's that hidden 1. So for that first case, the a equals to a 1, the hidden 1. Here, the a equals to a negative 1, right? It's a negative 1 that's hidden. This is what happens to the parabola. The parabola itself is exactly the same, and I'm going to do my best to make it look exactly the same. So pretend that it's just as wide, but what happens is the parabola will shift downwards. It's going to open the opposite way. So if it's opening up there, the negative will make it open downwards. And that's what a negative number for the x squared does. It makes the parabola open in the opposite direction. So if we look at the last problem where it's a equals to negative 2, we have a negative 2 in front of the x squared, two things happen to the parabola. First of all, we know it's a negative, so now we know it's going to point downwards. But we also know there's a 2 which is greater than 1, and if you remember from the previous slide, if the number is greater than 1, the parabola will narrow. So here the parabola is going to be narrower and it's going to open in the opposite direction. So it's going to be narrower than the baseline, and it's going to open in the opposite directions. So compared to our baseline, it's narrower and it opens in the opposite direction. Let's say if I were to draw this particular, so if this, I were to draw it here, just for comparison's sake, just so you can visualize exactly what happens. So nothing happens aside, in this case, the parabola switching down. Here, again, if I use my baseline, and I'll label it as such in just a second. So this is y equals 2x squared, y equals 2x squared. So if it was just a negative, all it changed was the actual sign, the value is still 1. The parabola simply flips. In this case, the parabola flips, but because it's now a negative 2 instead of a 1, it not only flips, it narrows down as well. So you can have more than one modifier to the parabola. So in this case, the sign is different, so the parabola flips, and the number is higher than 1, so it is narrower. Good. So let's take a look at it in one last case. So let's say I have these three quadratic equations. Our baseline, again, the y equals x plus squared, and we know how that looks. And then we have two new cases. Now, if looking at these two, the x squared, this isn't changing. There's still a 1 in front of both, and it's a positive 1. So the parabola is, in both cases, opening in the same direction, the positive direction, and it's the same width. But what changed here? Here you had a plus 0. Here you have a plus 3. How will that change this particular parabola? And over here, I just added pretty much everything to this. The number in front of the x squared is negative. It's less than 1, and we have that plus 3. All right, terrific. So let's go ahead and draw these out and see what they look like. So that's my baseline parabola, the y equals x squared, again, as close as I can get it to the actual one without graph paper. And I'm going to redraw it here. This is the y equals 2x squared, not the y equals x squared plus 3. So this is the y equals 2x squared, the same parabola. So what changes in the middle? The plus 3. Well, the plus 3, it's going to change the vertex, the location of the vertex. Remember, the vertex is the lowest or the highest point of the parabola. In this case, it's the lowest point of the parabola, right? So it's right over there. This is the point of the vertex. So what this is going to force the parabola to do is shift the vertex up by 3. Why up by 3? The number is positive. That means you go up instead of down. And on the y-axis, you go in the positive direction. And you go up 3 units because the number is 3. So let's say 1, 2, 3. My new parabola is going to look like this. It's going to be the same width, except, so this is this, except it simply shifted the vertex up by 3 units. That's all that happened. Alright, let's take a look at the next problem. Here's again our y equals x squared, our baseline. This is the new parabola. Now see what happened. First of all, number is negative. The parabola opens downwards. The number in front of the x squared is less than 1. It becomes wider. And the plus 3 means the vertex is shifted up 3 units. So it's going to point down. It is going to be wider. And the vertex, in this case now it's the top of the parabola, gets shifted up by 3 units. Alright, that's all the time I have today for this lesson. I'm going to do several problems from this homework session in a video that's going to be posted right alongside with this. So if you still have a few questions, watch that video please, and I'll see you back in class.